Hello, today I'm going to explain about tensile profile of mild steel and aluminum alloy by group 2. At first, meet my group members. Number 1, Cheng Huizi. Next, Muhammad Hakim. Third, Muhammad Iqbal. Fourth, Muhammad Hafiz and Muhammad Amar. The objective of this experiment is to measure the key mechanical properties of materials such as yield strength, ultimate tensile strength, modulus of elasticity, ductility, and fracture characteristic. Number 2, to compare the tensile behaviors of aluminum alloy and mild steel based on their stress-strain response. And last, to understand the influence of microstructure and bonding on the mechanical properties of different materials. Introduction. Tensile testing is a basic and widely used method to study how material responds to forces. It helps measure key properties like yield strength, tensile strength, elasticity, ductility, and fracture behavior. It is important for material selection, design, and failure analysis. In this experiment, we will test the tensile strength of aluminum alloy and mild steel. These materials have different structure and composition, leading to different mechanical behavior. Mild steel is strong and ductile, while aluminum alloy is lightweight and corrosion resistant. We will learn how to use the universal testing machine, interpret stress-strain curve, and understand how a material's internal structure affects its performance. This experiment supports the EMT2083 course, goals in mechanical testing and lab skills, and prepares us for future studies in material technology. We used two materials in this experiment. First, mild steel, dumbbell shape ASTM D638, and the second one is aluminum alloy. It's dumbbell shape ASTM D638. And next, method.
Before we start the measurement, first of all, we need to check the zero error.
At first, we have to measure the sample by its length and width. We have to measure the sample 3 times to get the average. After that, we have to measure initial gauge length for both samples, and we have to write down on the notes. For the next step, we have to perform a tensile test for both samples. Analyze the tensile profile, stress-strain curve of the sample. We need to determine the percentage of elongation, percentage of area reduction, Young modulus, yield strength, and ultimate tensile strength of the sample.
Right now, we'll proceed and perform the tensile test to the aluminum alloy. We'll first key the thickness, width, and the initial length of the aluminum alloy. Then we'll start the machine with the speed of 8 mm per minute. We check the zero error again to ensure the accuracy of the final results. Right now, we are going to measure the final gauge length for both the sample that is mild steel and aluminum. You should also measure its final thickness, width, and also its final gauge length in order to calculate the percentage of elongations and the percentage of area reduction. Measure and record all your measurements for at least 3 times in order to increase the accuracy of the result. Right now, we will observe the fracture surface for both mild steel and aluminum alloy. A cap and cocoon shape of fracture surface means that sample with a more brittle behavior properties. And here is the result. A graph for both samples, which shows that the peak stress and the Young modulus for both samples, and we can observe the UTS for both samples at the same time.